And then do you want to, once you see Sarah, can you promote her?
Yep.
I see you're in there. Hi, everybody. We're going to give it like 2 minutes for folks to trickle in. I have some intro slides for you, and then we'll pass it on to Russ. And Julie, you can see my title slide, okay?
Mm-hmm.
Okay, great. All right, it's 6:02. Thanks everybody for being here, for sharing your evening with us. I'm going to go ahead and get started because we have a lot to cover tonight. So we tonight are going to be talking about heat pump water heaters for residents. My name is Callan Damon. I work with the County Marin in the Community Development Agency on the sustainability team. And I'm joined by Julie Chu, who's going to be helping with our media tech. I'm going to hand it off to her for our kind of webinar how-tos pretty soon. And we're also joined by Sarah Thatcher, who is new to the team. She's going to be heading up the Electrified Marin program, which I'm also going to talk about a little bit later. So, webinar housekeeping. Julie, do you want to take that away?
Yeah. So for tonight's agenda, we have our main program presentation that'll run for about an hour. And after the presentation, we'll have some time for Q&A. Please enter your questions into the Q&A box. You can upvote on questions that you want to get answered from other attendees. All attendee mics and cameras will remain off for the duration of the session. Use the chat box if you have any general comments that you want to make. Live transcript and closed captioning is available. You can enable it by clicking on the CC icon in your menu panel. The video will be recorded and slides and other materials, and the recording will be sent to you via email, and they will also be made available on our website in the future.
Awesome. Thanks, Julie. All right, moving on. Just a little bit about the county sustainability team. So the county sustainability team works to promote healthy, safe, and sustainable communities while preserving Marin's unique environmental heritage. The team has developed programs to promote renewable energy, address climate change, encourage green building, and recognize green businesses. These policies and programs will ensure that the county of Marin is healthy, vibrant, and sustainable for many generations into the future. As Julie mentioned, we have a great website. And actually, it's marinsustainability.gov. I'll change that before I send that out. We just changed over to a .gov thing, and it's caused some confusion. We also have social media posts, so we don't get too crazy on there. We basically just promote things that are happening in the community, sustainability related, including events like tonight's webinar. And here's my contact information. If you guys have any questions about the information you hear tonight or any of your projects moving forward. So I'm going to keep these intro slides brief so we can get to Russ and learn more about heat pump water heaters. But I did want to point out that we've recently finished our electrification info hub on the county website. So we did that as part of an electrification roadmap to kind of identify, what we need to do and what the county can do specifically to promote electrification in Marin. And one of those actions was to make an info hub. So on the info hub, you can find resources on current incentive programs, including, state and local rebates, federal tax incentives. Again, I'm going to be sending out these slides and all these links will be live, so you can go to these websites directly. Rewiring America is a great website to kind of enter your home information, income levels, and see exactly what you qualify for under the Inflation Reduction Act, which for now is still happening, but I don't have a crystal ball into what's going on in the country right now, but for now, it's still a law, and you are able to take advantage of those tax incentives and rebates. There's also information on energy audit programs and concierge services, which can help homeowners kind of navigate these projects. That's a good thing to check out if you need to, someone to kind of help you through the process. We also have project ideas and info. I did want to point out that San Mateo did a 10-home cost study analysis for full electrification. There's some great information in there worth checking out. You can maybe find a home similar to yours and see, what the cost estimates were for doing some of these projects and what they would need to do to accomplish those. And then for local examples, every year we've been doing the Marin Green Home Tour. So these are folks in Marin that have done sustainability projects to their homes, and we have interviews and project information that you can learn more about. I'm going to go through these briefly, again, because I'm going to be sending out these slides so you can check out these programs later. But two, just right here, the Rising Sun Center for Opportunity Greenhouse Call program that runs every summer. They provide free energy saving kits that include LED light bulbs, smart power strips, faucet aerators, and more. And then a Home Energy Score is an in-person home energy assessment program for single family homes. It's really a good way to get started. A home assessor comes out to your home and gives you a score between 1 and 10 that tells you how efficient your house is compared to similar sized homes. It's actually one of the more inexpensive things that we promote because it's, can range from about $200 to $400 depending on the size of the home and the assessor. And there's a $200 rebate for each home score done. And it really gives you a good roadmap into, making improvements for your home from a third party eye, which is great. Some additional resources, indoor air quality. That's one of the reasons that we promote electrification is getting gas appliances out of the house. So we have some information on induction cooking, solar and battery for resiliency considerations, and then Fire Safe Marin for they have resources on home hardening. They also have some rebate programs for making your home better prepared for wildfires. At the end of the webinar today, please help us by filling out this survey. We're going to be sending out these solar battery chargers to some lucky folks that win the opportunity drawing. I've heard that we can't call it a raffle because that's like gambling, but if we call it an opportunity drawing, we're able to do it. So it's an opportunity drawing. And I'll be putting that link in the chat later and also in the email that we sent to everybody. So that is it for me. Promise I'd keep it quick. I'll pass it off to Russ now. Just for me to give a short introduction to Russ. Russ King has worked with us for many years, educating our building departments on Title 24, which is the energy code. We're really lucky to have him. He's an expert in all this stuff. And yeah, that's why we brought him in, because he's the best. So Russ, take it away.
Some thanks, guys. So I assume you guys will keep an eye on the Q&A and the chat, and then questions you can answer, you will. And if not, if it's part of what I'm talking about, feel free to interrupt me, and we'll get those questions answered as they come up. So thanks, everyone. Thanks for being here. I really appreciate it. Let me share my screen. Is that working? Can you see me okay?
Yep, looks good.
Okay, awesome. All right. Well, thanks again, everyone. Great to have you here. We appreciate you spending some time out of your day. It's a pleasure for me to be here and share this information to you. So what we're going to talk about today is heat pump water heating. And just the agenda, we'll do a little introduction, and we're going to go through some super basic thermodynamics and the refrigeration cycle. I hope that doesn't put you to sleep. I'll try very hard not to let that put you to sleep, but I think it's very interesting. It's very important part of understanding how heat pumps work. And so we'll talk about that. We'll talk about the advantages of heat pumps for water heating. We'll identify different types of heat pump water heaters, what's available out there, and then some special considerations about heat pump water heaters and kind of the disadvantages of heat pump water heaters. And then at the very end, we'll have an open discussion. Just a brief introduction. of myself. I'm a mechanical engineer in 3 states. My company is Coded Energy. We're developers of a new 3D HVAC design software, and I've been doing this stuff for a long, long time. My first job out of college in 1988 was doing energy calculations for Title 24, and then I went into mechanical design. There's my email. Feel free, if you have any questions, feel free to email. I have a blog about HVAC topics. It's kind of homeowner facing, but it's also HVAC contractor facing and stuff like that. There's our website. We have a YouTube channel called Quick Model, and then I wrote a book on HVAC. It's called Introduction to Residential HVAC, and a lot of the images that you see in this presentation are actually from that book. So it's very nice to be here. I appreciate it. All right, so let's talk about heat pumps in general first, and then we'll focus on water heaters. So to really appreciate heat pumps, you must first understand a little bit about how and why we heat water in our house. All right. The primary reason that we heat water is for what we call domestic hot water. And that's your usual bathing and your hand washing and your dishwashing and all that good stuff. Okay. Some homes have water heaters that are used to heat the space, to heat the air. All right. And so it'll be a water heater that sends hot water to some sort of, it could be under your floors, like radiant floors. It could be baseboard heaters. It could be a little air handler unit that's ducted and sends hot, warm air to all the places. That's called hydronic heating. All right. And that's a little different. Heat pump water heaters can be used for hydronic heating, but they're mostly dedicated to domestic water heating, which is our showers and all that good stuff. Okay. Because excessive use of energy also has negative impacts, we want to heat this water as cheaply and efficiently as possible. All right. One of my favorite sayings is that the greatest energy resource that we have in the United States, energy resource that we have in the United States is not gas, it's not oil, it's not coal, it's not solar, it's not wind, it's not hydro. All right. The greatest energy resource we have in the United States is the energy that we waste. All right. We waste almost 2/3 of the energy we use. What that means is we could accomplish the exact same thing, the exact same amount of hot water, the exact same temperature in our house, the exact same level of lighting and all that stuff, and use 1/3 the energy. And if we could do that, we wouldn't need all these other sources of energy. All right. And not only that, but using less energy has so many other benefits. It costs less, so it saves us right in the pocketbook, and it reduces all the environmental impacts as well. All right. So energy efficiency really should always be the first option. All right. And in the next week we'll have the heat pump for space heating class, and I really emphasize that a lot, that you make your house efficient first before you put a heat pump on it. Okay. But so we're so the point is that we're trying to do this as efficiently as possible without sacrificing what we're used to, what we want. Okay. We want hot water when we need hot water. We don't want the water to turn cold when we're taking a shower and things like that. So that's all very, very important stuff. But if we can do all that and save energy, then it's a win-win. All right. So there are two basic types of water heaters in the way they work. All right. And the two basic kinds of water heaters are instantaneous, all right, also known as tankless. So the water comes into it and cold and it comes out hot. It's just straight through. Comes in cold, comes out hot. We call that an instantaneous water heater. Those take a lot of power, whether it's gas or electricity. They take a ton of power to do that. I imagine 50-degree water coming in at a pretty steady rate and instantly heating that water up to 120 degrees. That takes a lot of heat to do that, a lot of electricity or a lot of gas. All right. The other kind is a storage water heater. And what that does is it's a big tank. All right. And we keep a large amount of hot water in that tank. And we can draw off that tank as much as we want. Okay. To a point, of course, right? And then cold water comes into that tank at the same rate that we pull hot water out of it, and over time it gets warmed up. All right, so that's a much more convenient way to do it because we can warm that water up slowly. The disadvantage of that is that, well, let me get to my next slide. Let's talk a little bit more about instantaneous. So water is heated, the incoming cold and hot water comes out instantly. All right. Other names for it is on-demand water heaters, tankless water heaters, and things like that. I always chuckle when I see tankless. When they first came out, a lot of the word processing software didn't understand the word tankless and would autocorrect to thankless. And so, like, you see all these articles where they're talking about thankless water heaters, and you knew that they didn't proofread their stuff very well. So I always remember that. But the advantages of a instantaneous or tankless water heater is that hot water comes out as you need it. So you don't have to pay to keep it hot when you're not using it. All right. So those are great for like uh um you know, homes that you visit, vacation homes, cabins up in the mountains where there's not going to be the people there all the time. And so you go up there and you turn it on and boom, you get hot water instantly. All right. And you're not paying to keep this huge tank of water hot all the time. And we call those standby losses. The need to, if a tank of water is just sitting there and it's losing heat and you have to keep adding heat to it, even though you're not using the hot water, that's called a standby loss. And so with um, tankless water heaters, you don't have any standby losses. Okay. The disadvantages is they require a very high input. Like a typical furnace needs a 1/2 inch gas pipe to it. A tankless water heater needs a 3/4 inch gas pipe to it. So it's that much more um, gas that's used to heat the water. And then electricity, it needs much higher uh, amps and all that good stuff. Okay, so when you're heating water that fast, there's some inefficiencies evolved. Some of that heat doesn't get into the water. It goes up the flue or whatever. Okay. It's harder to heat water that's moving by quickly. You have to try to slow that water down in order to heat it up. But you don't want to slow it down so much that you're not sending out the amount of hot water that's needed to take a shower or whatever. All right. So it can reduce flow rates. It can limit how many people are taking a shower at any one time. But if only one person is taking a shower, they can literally take a shower forever, forever and ever, take a hot shower. All right. But if you start having 2 or 3 people taking a shower, then it's not putting out enough hot water. Okay. Then on storage, you've got this huge giant tank, usually 40 to 80 gallons is very common for residential. And the water inside that tank is hot all the time, 24/7. All right. The good thing about that is you can have many people take a shower at the same time, and pull a lot of hot water, gallons per minute, off that tank. It's just that it won't last very long. All right. Um, you can take advantage of more efficient heating sources because you're not heating the water up so fast. You can heat the water more slowly. All right. You draw a bunch of hot water off to take a few showers, and then you stop using hot water, and now the water heater has time to recover. Okay. We call that recovery. And so we can also then we can start using things like heat pumps, which do heat the water much more slowly than gas or electric resistance, but they're much more efficient. We can also take advantage of solar water heating, solar thermal. Okay, and then, very, very interestingly enough, your water heater can actually be treated like a battery by the utilities. During the time of day where they have excess power and excess electricity, they can just say, "Well, let's just heat up some people's water to make their water a little bit hotter," and but then we can use it. We can take advantage of that, and so it's an interesting concept. Those are called utility tied or utility intertied water heating systems, and things like that. And a lot of the utilities will give you a discount on your electric rates if you take advantage of that program. Some people kind of say, "Oh, that's kind of Big Brother controlling my water heater," but they have something similar for thermostats, by the way. But you can override it at any point in time, and it allows the utilities to have grid stability strategies and things like that. So it's just a really fascinating thing. Um, the disadvantages is that the water can run out. All right. If you're using it faster than it can recover the water, you might run out of hot water. Standby losses, keeping the hot water hot when it's not being used. Okay. That can be reduced by better tank insulation, putting more insulation around the tank and things like that. Okay. So the two basic types of water heaters. Now, some people have in their homes a recirculating system. Okay. And if you have one of these, you really should think about it. Take a look at it and make sure. I've talked to people that say, "Yeah, we have one," and I'll say, "Well, what kind is it?" We're like, "I don't know. It just runs all the time." And so some of the old ones literally ran 24/7. And what it's doing is there's a little pump that pulls hot water out of the water heater, runs it through a big loop all the way through the house and then back into the water. And it's running 24/7. Okay, so it's pulling perfectly good, perfectly hot water out and basically running it through a heat exchanger all the way around the house. And so by the time it gets back to the water heater, it's quite a bit cooler than when it left. It has to replace all that heat. All right. And so it's just doing this all day long, 24/7. It's a really, really inefficient way to have a water heating system. All right, and so they've improved that somewhat by putting a timer on it and say, okay, well, let's only run it through the recirc system during certain times of the day. All right, that's definitely improvement, but it still uses a lot of heat. It wastes a lot of hot water to do that. Now they have some newer ones that are on demand. All right, you walk into your bathroom, you hit a button, it turns on a pump, you do whatever you need to do, you wash your hands, and the water's heated, the hot water's there. All right. And I forgot to mention that's the whole purpose is so we don't have to wait for the hot water to get there. If you go to, the bathroom that's on the far end of the house, and from the water heater and you turn it on, you may have to wait a minute or so to get hot water out. And some people just don't like that. Okay. So so that's one of the reasons for doing this. All right. Now the on demand or any of them can actually save water because you're not letting all that cold water come out of the pipes until the hot water gets there. So that saves water by having a recirc system, which is certainly important in California. Um, but the continuous ones and even the time ones are very, very wasteful. All right. So the new ones are on demand. Okay. And there's different ways to do it. There's one that's just an occupancy sensor that when you when you come into the bathroom, it turns on the pump, or there's a little button that turns on the pump and things like that. Okay. But here's the important thing. Make sure that that water pipe is insulated. Okay. Make sure it is insulated. In fact, if you have any work done to your water heating system, if you replace your hot water, the code says that you must insulate all accessible hot water pipes. Okay. And so if they're up there in the attic and you can see them and you can get to them, they have to be insulated. Okay. All right. So let's see, we got a question in the chat. Can you also please speak about integration of electric heat pump with solar electric? We produce electric solar and already have battery backup, but water heater is currently gas and we need to replace. Yes. If you have solar panels on your house, switching from gas to a heat pump is kind of a no-brainer. You own your own little power company. Why are you paying the gas company to heat water? All right. And the nice things about heat pump is they require a lot less electricity. You could theoretically put in, well, the code doesn't allow you, but we all know people do stuff without getting a permit and stuff. But you could theoretically put in an electric resistance water heater and have electric water heating. Okay. But then those use a lot of electricity. And so that's going to waste some of the electricity that you're producing and you may not get full benefit of it. But heat pump water heaters, from electrical standpoint, they don't require a whole lot of power. So if you have solar panels on your house, electric solar panels on your house, it's kind of a no-brainer. Okay. All right. Let's see here. Moving right along. So just a quick comparison of water heating fuels. Okay. So let's look at installation costs. Let's look at operation costs. Let's look at safety. Let's look at environmental impacts and let's look at performance. Okay. So gas, fairly low install costs if you're already replacing gas. If you have gas to your house and you have a gas water heater, it's very cheap to replace with another gas water heater, relatively cheap. Okay. The operating costs are fairly low. All right. The first house that my wife and I bought after we got married back in 1990, it was intended to be an all electric subdivision, but they found out that the new code made it very difficult to have electric resistance water heating. And so they had to put gas water heaters in these houses that they had already planned to put heat pump space heating in. So the only gas in our house was our water heater. And it was just the two of us. And our gas bill was about $5 a month. Okay. So that's not very much for water heating. But again, it was just the two of us. And when we got kids, it was, it quadrupled really quickly. So yeah, gas water heaters is relatively cheap. And replacing that with electric water heating is not cost effective because electricity costs much more per BTU. But that was electric resistance back then. They didn't have, or heat pump water heaters were not readily available back then like they are now. And so we'll talk about why electric heat pump water heaters are so much more efficient. And then safety. All right. I'm a mechanical engineer. I do a lot of residential HVAC design, and it always bothered me that we piped an explosive gas into our homes, and then when we used it, it turned into a poisonous gas, and people thought nothing of it. All right. And I was a proctor and I got trained for combustion safety testing and things like that. And the more I learned about it, the more I wondered how we survived this long having gas appliances in our homes. And I know people there's been some serious incidents. I had a house that I designed the HVAC system for, and a large family lived in a relatively small house, and they all started getting sick. And the builder called me and said, Russ, you're the mechanical engineer. Get out here and tell us, what'd you do wrong? And I was like, no, it wasn't me. Well, it turned out to be the gas dryer in the house. The little duct that comes out of the back of the dryer and goes into the wall had a kink and a hole in it. And a gas dryer, the air that's coming out of there has carbon monoxide in it. All right. So, anyways, I'm not trying to scare people. I'm just trying to say that personally, the one of the main reasons we're switching from gas to electric in my house is for safety reasons. Okay. And then environmental reasons. Whether you buy into it or not, there's a lot of good reasons to get rid of carbon-based fuel sources. Okay, so decarbonization, electrification, whatever you call it. All right, and then the performance side for gas water heaters, performance is great. Gas is very good at heating stuff. You got this huge blowtorch in the bottom of this tank, and it heats that water up really fast. All right. So then for many years, the only alternative to gas was electric resistance. And electric resistance is taking electricity and turning it directly into heat by running it through a wire that has some resistance in it. All right. So you apply a current to a piece of wire, and that wire glows red. All right. And it gives off heat. So that is directly converting electricity to heat. And that is actually really efficient. It's like 99.5% efficient turning electricity into heat. Now, why, if it's 95% efficient, 99.5% efficient, why aren't we using it more? It's that efficient. Water heaters are down in the 80%, range or whatever, their efficiency ratings are nowhere near 100%. All right. But electric resistance is so expensive. Why don't we use electric resistance? And the reason is the fuel source, electricity, is expensive. On a BTU per BTU basis, that's heat, electricity is way more expensive than gas. So even though it's much more efficient, it's not efficient enough to offset the fact that gas is cheaper. All right. So from a cost perspective, electric resistance just doesn't pencil out. All right. The installation cost is very cheap. If you replace an electric resistance water heater with an electric resistance water heater, that's the cheapest route you can go, which is why so many rentals have electric resistance water heaters. It's because they're really cheap to buy. The operation cost is very high. You're going to use a lot of electricity to heat that water. The safety's okay. Safety's not bad. The environmental impact's not bad. It's only bad because you're using so much electricity. And the performance is decent. Medium high, electricity will heat water quite quickly if you're using electric resistance water heaters. All right. Now we have much more availability of electric heat pump water heaters. The install cost is high. All right. The unit itself is expensive. And if you're replacing a gas water heater with an with a heat pump water heater, you're going to have to do some infrastructure work, and there's times where you may even have to upgrade your panel to do that. That's very expensive. But there's a lot of rebates out there, lots and lots of rebates, and that's why the rebates out there is to help offset that one main disadvantage that they have. Okay. Um, Operation costs are very low, especially if you have solar panels. All right, especially if you have solar panels, the cost is very low. They're very, very inexpensive uh, uh, to operate. Um, they are from the safety perspective, they're quite good. All right, they're nothing to complain about there. From an environmental perspective, they're excellent. All right. And their performance is low compared to gas and electric resistance. So you do have to be more deliberate about how you use hot water. All right. But there's a lot of really cool controls. You can control it with your phone. If it's a Wi-Fi base, there's some really neat stuff. And so just just by being a little more deliberate about how you use hot water, just understanding the principle of it, it's worth the effort. Okay. It's worth the effort. All right, so that's just a comparison. Let's see, a quick question here. We have an HVAC Mitsubishi system in our house. Can an HVAC water heater connect to our installed system? Not necessarily. So it sounds like you have a Mitsubishi, like a ducted mini split or ductless mini split. An HVAC water heater connect to our installed system. Only if the air handler, there are air handlers that they can set up that are both hydronic, so they'll pump hot water to it, but it probably won't do cooling. Okay, so probably not. Probably not. Your best bet is just to get a whole entirely separate heat pump water heater. Okay. All right. Okay. Here's, at the risk of making people fall asleep, we're going to talk a little bit about thermodynamics in the refrigeration cycle. But maybe this is the first time it's been explained to you in a way that really makes sense. So hopefully that's the case. So the first thing we need to do is define heat. Heat is defined as a British thermal unit. Okay, BTUs. It is a unit of heat energy that's about the same amount of heat that's stored in a wooden match. So if you take a match and you strike it and you let it burn all the way down to the nub and throw it down, you've just released 1 BTU of heat into the air. Okay. Now, if you take a box of matches, you do that same thing as fast as you can. You're doing a certain rate of heat. You're putting heat into the air at a certain rate, or BTUs per hour. So how many matches can you strike and let burn down in an hour? Okay. So let's say if you could do, let's say it takes 5 seconds. All right. So he's 5 seconds. Well, that would be 12 per minute times 60. All right. So that's how many BTUs per hour you'd be putting into the air if you could strike matches. All right. Now that helps you put into perspective things like a 120,000 BTU furnace. There's people out there, you or your neighbors may have a 120,000 BTU gas furnace in your house. That is burning 120,000 kitchen matches worth of heat in an hour. That's a lot of kitchen matches. Okay. Now that's a big one. That's on the high end of furnace sizes. A more common would be like 60 or 40. They get down to 40,000 BTUs, but that's still a lot. And when you do a heating and cooling load calculation on your house to size your equipment, that comes back to you in BTUs per hour. So that's telling you how many kitchen matches per hour your house loses in the wintertime and gains in the summertime. And that helps you size your equipment. Okay. So BTUs per hour. If it helps to think of them as kitchen matches per hour, then think of it that way. I think that can be very helpful. So when you see in our images, you see this little kitchen match kind of flying through the air. That represents BTUs. Okay. Kitchen matches are BTUs. All right. So when we say temperature, when we measure the temperature of something, what we're actually measuring is the density of BTUs. How many kitchen matches are in that particular mass or volume? All right. And if you have a mass or volume, like a jar full of water, and it has a certain amount of BTUs in it, you can measure the temperature. And then if you add BTUs to it, the density of those BTUs goes up, the temperature goes up. And if you remove BTUs, the temperature goes down. So think of temperature as a measurement of the density of BTUs, either in an object or fluid or air or a house or something like that. Okay. Everything has some BTUs in it. All right. Everything on this entire planet has some BTUs in it. Even the coldest block of ice you can imagine has some BTUs in it. Okay. It's just not very many, and they're not very dense. And that's why it's so cold. The only place you can go where there's no BTUs is outer space. All right. The vacuum of space has no BTUs in it. All right. But on the planet Earth, even a block of ice has some BTUs in it. Now, a a glass of warm water has more BTUs in it. A glass of hot water has even more BTUs in it. All right. So everything has some BTUs in it. When we heat something, we're adding BTUs, and we do that at a certain rate, kitchen matches per hour. Okay. When you add BTUs to something, it gets warmer. Okay. BTUs, think of these BTUs as being antisocial. They don't like each other. All right. So you got a whole bunch of BTUs in this block of metal and not so many BTUs in this block of metal. When you put those two BTUs together, they're like, hey, let's go over there. There's not as many of us. Let's get out of here. Let's go where there's not as many other BTUs. And they go to where it's cooler, where there's less BTUs. So heat will naturally flow all by itself. You don't have to do anything to make it move. Will move all by itself from something that has a lot of BTUs that's warmer to some place that has less BTUs that's cooler. Okay. And we call that the second law of thermodynamics. That usually puts people to sleep right there when I say that. Second law of thermodynamics. Don't worry about it. It's not a big deal. Just know that heat naturally goes from warmer to colder. Okay. All by itself. It just does it. Right. Okay. Now, here's another interesting thing that a lot of people don't realize. So if temperature is the density of heat in an object, if you make that object bigger without changing the number of BTUs, you reduce the density of the BTUs, which means it gets colder. All right. So if you have a certain volume of air that has a certain number of BTUs in it, and in this example, there's 9 BTUs, there's 9 kitchen matches in this volume. And if you make that volume bigger, you put a vacuum on it, you expand that out and make the volume bigger with the same amount of BTUs in it, it gets colder. You can feel it get colder. And then the opposite is true too. If you decrease the volume, you smash it down, you're increasing the amount of BTUs in there, and it gets warmer. So you can change the temperature of something like air or another kind of gas by changing the volume without changing the heat. Okay. So bigger is cooler, smaller is warmer. Bigger, cooler. Okay. Smaller is warmer. Hot, cold, hot, cold, hot, cold. All right. Then if we do that, the fact that heat will move from warmer to colder, we can then start making heat move where we want to. All right. So let's say we have 70-degree air that has a certain amount of heat in it, right? A certain density of BTUs in the 70-degree air. And we have this little container, and then we expand that gas and make it colder so that it's less than 70 degrees. We make it 40 degrees. Those BTUs are going to go, hey, look, there's less BTUs over there. Let's go over there to where it's 40 degrees. And they're all going to naturally go into that. All right. And then we take those BTUs and we squish it down, and it makes it hotter. It makes the density higher. It's 100 degrees. Now the BTUs want to leave. All right. And so we've made BTUs go into this container by making it colder than the air. And then we've made it leave by making it hotter than the air. Okay. What if we sorry, I got a little behind my side, so we can make it leave by squeezing it down. All right. The ability to mechanically change the temperature of a fluid by changing its volume is essentially how the refrigeration cycle works. Okay. So it takes that concept of and I like to think of it as a sponge. All right. If you take a sponge and you squeeze all the water out of it and you put it in water and you let it expand, it absorbs water. And then you bring it over here and you squeeze the water out. And you go back over here and you expand it. So you can move water from one place to the other by expanding and contracting the sponge. That's exactly what this gas does. And this gas is a very special thing called a refrigerant. You've probably heard of Freon, and you'll hear things like R410A. That's a very special gas that by compressing it and expanding it, it does a really, really nice job absorbing and expelling heat. Okay. It has a special property that makes it very, very efficient at that. All right. So we can take that concept and say, okay, let's say we have a house and it's 90 degrees outside, and it's 70 degrees inside, the heat is naturally going to want to come in. All right. And if the heat just keeps coming in and coming in, pretty soon the inside of the house is going to be what temperature? The same as outside. It's just going to keep going until the temperature equalizes, and then the BTUs are going to stop moving. All right. Now, we don't want that to happen. We want it to stay 70 degrees inside our house. We want it to be cool inside our house. So as that heat is coming in, we need to remove it at the same rate. All right. If it's coming in at a certain BTUs per hour, we need to get it out at the same BTUs per hour in order to stay comfortable, in order to maintain that indoor temperature. Well, now we've got this BTU sponge. Let's see what happens. All right. So we take our BTU sponge, we bring it inside the house, we expand it to where it's 40 degrees, and then the BTUs are going to go inside there because the house is 70 degrees. So the heat will go from the 70-degree house inside this container. And then we take the container outside and we squeeze those BTUs out. And the reason we can do that is because we can make that fluid hotter than the outside air. All right. So it's 90 degrees outside and we make that fluid 100 degrees. The BTUs are naturally going to leave that thing. So that's exactly what we've done. We've created a BTU sponge. All right. So by going in and out and in and out and in and out, all right, we can take BTUs out, but we've got to do that very quickly because they're coming in through our windows and our walls and our leaks and insulation, all that stuff in our house. The BTUs are coming in. So we got this little container. We're going back and forth. Well, that's not very efficient. All right. We don't want to do that. All right. So someone, a very, very smart person, came up with a very ingenious way of doing that. Instead of having individual containers that we capture the heat in, they said, what if we just make a continuous loop of refrigerant? And we have the refrigerant being squeezed out over here, and then we have it being expanded and absorbing heat on the inside. And so it's this continuous loop of refrigerant. That's exactly what an air conditioner is, okay? And so this image here shows an air conditioning cycle where we're pulling air out of a cool house by expanding that refrigerant, making it colder than the house so it absorbs the heat. And then we take it outside and we squeeze the heat out. And it's a continuous loop of refrigerants going, brrr, it's running through. That's exactly what your air conditioner does. So the inside of the house, we call that an evaporator. The outside of the house, we call that the condenser. Okay. So, sorry. Excuse me. I think I need to look at here. Okay, so that's exactly what it does. So it expands inside the house. We take it outside and we squeeze it out. But think of it as, instead of big jars, think of it as little teeny microscopic jars. And there's just a whole stream of them just continually going through. And then eventually our house gets to the cool temperature and a thermostat says, oh, we're good. And then it shuts off. And then the heat starts coming back in the house. And then the thermostat goes, oh, I'm getting warm, and it turns that loop back on. All right, it's thermostat, air conditioner. That's exactly what that is. All right. And then this is cool. You can go the opposite direction. All right. If it's cold outside, even if it's really cold outside, you can make that refrigerant colder. All right. How cold can you make refrigerant? What's the coldest deep freeze you've ever had in your house? What, a chest freezer or the freezer in your refrigerator? How cold can that get? That can get really, really cold. And the reason is because the refrigerant can get even colder. And whatever heat gets in there, if you put something warm in the fridge, you put in, a tray of water to turn to ice. That water has BTUs in it, and the refrigerator can get colder than that space. Take those BTUs out of the water and throws them outside the refrigerator, which is in your kitchen, by the way. Okay, so we take that concept and we put it in our house. That's called a heat pump. That's exactly what a heat pump is. A heat pump is an air conditioner that runs backwards. Now, we don't have to, when the heating season comes around, we don't have to take the evaporator and set it outside and bring the condenser and bring it inside. Okay, what happens is, very cleverly, inside the heat pump condenser, there's a little valve that switches direction, and the refrigerant starts doing the opposite thing. It's really cold outside, gathers heat, brings it in, it's compressed, it makes the refrigerant very hot, hotter than the inside air, and then the BTUs come out. All right, so it's pumping heat in the opposite direction. Okay, so that's your basic refrigeration cycle. I hope that helped. Now you can take the same concept and apply that to water. All right. Wherever your water heater is, or wherever your water heater is sitting, there's air around it. And there are some BTUs in that air. If you can capture those BTUs from the air by making the refrigerant colder than the air is going to give its BTUs to that cold refrigerant. And then you take that refrigerant inside the water tank and make the refrigerant hotter than the water, then the BTUs come out. Okay, very simple in concept. Kind of complicated in practice, but that's why we have technicians who are good at charging systems and stuff like that. But okay, so great. All right, so that's how it works. Now, what's the difference between that and just heating our house with electric resistance? Okay, so what is a heat pump? Heat pumps are electric heaters. Rather than using electricity to create heat, which is what electric resistance does, electric resistance takes electricity, converts it directly to heat. You put a voltage, put current through a wire, and that wire gets hot. That's turning electricity. That's 100% efficient, 99.5% efficient. How in the world can we beat that? How can we be more efficient than 99.5? Well, here's the deal. Heat pumps cheat. They're cheating. They are. They're not creating heat. They're stealing it from somewhere else. They're stealing heat from the air, the heat that already exists. So heat pumps are cheaters, okay? But they cheat in our favor. And so as it turns out, it takes 1/3 the amount of heat to steal it from the air, or 1/3 amount of electricity to steal heat from the air than it does to create heat. So guess what? Heat pump water heaters can be near and more than 300% efficient. 300% efficient. That's like, most people think that's impossible. How can you possibly be 300% efficient? And it's efficient in using the way it uses electricity to create heat. Okay. It does not create the heat, it steals the heat that's already there. All right. And the more heat that's there for them to steal, the better they work. Okay. So this little diagram just shows you got 5 units of electricity, BTUs of electricity, and you can turn that into 5 BTUs of heat, electric resistance. That's really efficient. But in heat pumps, you have 2 units, 2 BTUs worth of electricity, and it's capturing 5 or 6 BTUs it's stealing BTUs from the air. And for 2 BTUs worth of electricity, you're getting 5 or 6 BTUs worth of heat. All right. That's why it's so super efficient. Now we can start competing with gas on a cost-effective basis. Okay. It used to be a simple formula that they used to say electricity was 3 times more expensive than gas on a BTU per BTU basis. Electricity was 3 times more efficient or more expensive than gas. So in order to compete with gas, we had to be 3 times more efficient with it. And now we are. We're up in the high 2s and over 300% efficient. So now we compete with gas. It's not as simple anymore because now we got time of use rate. So electricity, the price of electricity doesn't sit still long enough for us to do a fair comparison. So you have to look at it over a longer period of time. Okay. But anyways, that's the whole concept. BTU steal heat that's already there. All right. And if steal is a bad word, I don't care. Borrow, I don't know. But they're stealing on your behalf, and it's a good thing. Okay. All right. So heat pump water heaters, they use the refrigeration cycle to move BTUs from the air around them. All right. They capture air, they remove BTUs, and they put it into the water. All right. Now, when I say remove BTUs from the air, what's another way of saying that? Another way of saying that is that they cool the air. They when you take BTUs away from something, you're cooling it. So it brings in warm air, it extracts the BTUs, and it gives you back cold air. That's either good or bad, depending on your perspective. Okay. So it takes the air, whatever heat is around it, it extracts that heat, puts it in the water, and gives you back cold air. All right. Now, that's bad if it's blowing into your house. Okay. And it's bad if that water heater is in a very confined space, that it's going to take all the air out of that space and cool it, and pretty soon that air gets colder and colder. And remember what I said a minute ago is the more BTUs that are available to it, the better it works. And the opposite is true. The less BTUs that are available to it, it doesn't work as well. It's not as efficient. They'll work down to very, very low temperatures. Space heating water heaters will work down to the negative degrees, okay? Fahrenheit, not Celsius, negative Fahrenheit degrees. All right. So that all they have to do is they have to make that refrigerant colder than the outside air in order to extract heat. And heat pump water heaters will do that. Is they just don't do it as well. They lose efficiency. Okay. How cold? I said this before. How cold can it be before a heat pump will stop working? What's the coldest freezer you've ever seen? Okay, gone into a refrigerator. I worked on 2 summers on a salmon boat, and they had a blast freezer in there that could freeze a whole salmon in just a few minutes. It got really, really cold. And that's because they can make the refrigerant colder and absorb heat. All right, so they can make refrigerant really, really cold. So they're efficient and they work in cold temperatures. Okay. Um, all right. So what are some of the advantage of heat pumps for water heating? Well, they're safer. All right. If you go look at if you go into a typical house and look at the gas water heater sitting there, whether it's in the garage or a room somewhere, and just look at it, there are so many hazards associated with that. All right. There's code that says they have to be up off the ground. Why is that? Is because there's an open flame inside there. And if you have gasoline or any other explosive fuels or gas vapors, they can explode. All right. So that's one problem. And then look at the top of a gas water heater. Go look at the top of your gas water heater. If it's a typical one, there's gonna be a gas flue pipe coming off of it. All right. And there's gonna be this little metal cone. And usually they're cockeyed, they got knocked over and they're off at an angle or something like that. But there's a little cone and you can see through it. You can see actually through that little cone. And there's gonna be a hole in the top of that water heater. When that water heater is on and the gas starts burning, all those vapors, all that warm, hot combustion products rises up, okay? And it has to push the air that's in that pipe. And so they put this little cone there because it allows the gas to escape around it until it can finally push that air up and it starts pushing the air through it. And then it's called drafting. Then it starts pulling it up through the pipe. Okay. It is allowed to do that for 60 seconds. So for 60 seconds, every time your water heater comes on, combustion products are spilling into the garage or wherever your water heater is. Okay. That's a dumb thing to do. Okay. And then if that thing gets all cockeyed, or if a bird builds a nest in your vent pipe, okay, it won't flue, it won't draft, and then you get all the stuff spilling into wherever the water heater is. So, anyways, I'm sorry, but safety is a big issue with me, and it's honestly it's amazing that there aren't more accidents related to gas water heaters. Okay, so water heaters, there's no explosion danger, there's no poisonous gases, there's no fire hazards. Okay, unless you have an electrical short or something like that. This is a great quote. The potential for something to go very, very wrong with a gas burning appliances is much higher than people realize. This is why CO detectors are required when you pretty much do anything in your house. If you get a permit to install a sink in your house, you know what they're going to make you do? They're going to make you put a carbon monoxide detector in your house. That has nothing to do with your sink. And the reason is that it's really, really important that all houses have carbon monoxide detectors. It's that important. That is a mandatory measure. No matter what you do, you have to put carbon monoxide detectors in your house. Okay, so it's that important. It's that important. Another big advantage is that there's from a new construction perspective, they're actually cheaper to install. It's very expensive to run gas pipes to a house. It's very expensive to put flue pipes and penetrations up through your attic. It's even expensive to provide that appliance with combustion air so that it can breathe. Right? If you have a gas water heater in a closet, you've either got louvered vents in the door, which is a very bad idea because now it's exchanging combustion air with the house, or you open that door and you'll see a screen vent in the bottom and a screen vent in the top. That's so oxygen can pass through that closet and allow the thing to breathe. And people throw, carpet and put buckets on top of these things, and now the water heater can't breathe. All right, so it's very, very potentially a very hazardous situation, and you simply don't have that with heat pump water heaters or electric resistance for that matter. Okay, maintenance. They are lower maintenance in a way. In a way, they are lower maintenance. Gas burning appliances must be checked and adjusted regularly. Gas burner ports can become clogged or dirty. And there are safety devices that can fail in a gas furnace and a gas water heater. If you open if you open a gas furnace, you take the panel off and you see all these wires and sensors and tubes and everything, 90% of that is safety devices, okay? 90% of the stuff you see inside of a furnace is for safety reasons. Okay? And then if you open up a heat pump fan coil unit, you hardly see anything. You see a motor and a coil and some wires, and that's it. All right. Much safer. All right. However, I will say this, and this has been a thing that people have actually complained about. They weren't properly warned. Heat pump water heaters do require maintenance. Okay. Because the air is passing through them, there's a filter, and that filter has to be changed. And if you don't change that filter, it can affect the efficiency of the water heater. So you have to do it on a fairly regular basis. You just clean it out, wash it out. Okay. All right. Sorry, bear with me. All right. So another one is their cleaner. No carbon emissions. You can utilize rooftop renewables, solar, wind. If you got wind in your house, not many people do, but some people do. It's awesome. All right. Good stuff there. They are super efficient, up to 300% or more efficient. That's amazing. And the technology is awesome. There you can get them Wi-Fi based, so you can actually control. It's funny to talk to people who've just put one of these in. My brother-in-law put one in his house. He's like, "Oh, my water heater is blah blah blah. And it's been running for 4 minutes. So that's very interesting." And he's all really, and he graphs it out and everything. It's really funny. The more information you have, the more efficient you can become. All right. Um, they are cost effective. They can easily compete with gas in most marketplaces. Okay. Oh, listen, we got a question here. How much more efficient is it to heat water with solar than using electric heat pump water heaters? How good are the new solar water heaters? Well, once you put it in, solar is essentially free, except for a little pump that turns. Okay. The problem is that putting it in is quite expensive. All right. Solar water heating is coming back, and it is quite efficient to do that. Okay. All right. Let's figure out all that. All right, disadvantages. They're more complicated. Your average plumber, your average everyday Joe plumber with the thing in the back, um, don't like working on heat pump water heaters because they have refrigerant in them and they're not used to doing that. Most plumbers are not used to doing that. So it is more complicated. It requires more qualified technicians, just like cars are getting so complicated. Cars are basically rolling computers these days. And the industry has had to adjust for that. The garages have had to adjust for that. All right. And the same thing is going to happen for water heaters. Okay. It will adjust. They have more complicated controls, and if you don't set them correctly, that can be a big issue. So you do have to be very deliberate again about how you set the controls. They can be a bit more difficult to operate, and they require more attention. Okay. All right. Let's see. Grid reliability issues. If we start putting more and more stuff on electricity, it affects the grid. Okay, so we do need to be careful about that. The grid is improving every day. Where we get our power from is improving every day, and it's moving from dirty electricity to clean electricity. Eventually, it's going to be clean electricity. Okay, so we may as well change our water heaters now. Okay, if you buy a water heater today, it's going to last a long, long time. And somewhere along the way, you're going to wish you would have put in an electric water heater. Okay. All right. So all of the disadvantages of heat pump water heaters are avoidable, and they're getting better over time. Okay. All right. So, question: they require more attention. What kind of attention? Mainly, um, depending on the type of setting that you have. Okay, and they require that filter be changed out. All right, you got to make sure you change your filter, and then they have a lot of controls on them. They have like there's like vacation mode and booster mode and efficiency mode and all these different modes that you can change very easily with your phone. You just have to remember to change it back. Okay, there's a mode for when you have all your family over at Christmas and you have people staying at your house, or a lot of showers being taken. there's a mode for that. All right. And most heat pump water heaters have electric resistance backup. So they will kick into a booster mode, but they're less efficient. All right. And so you want to be sure to change it out of that mode. Don't accidentally leave it in that mode. Okay. And the kind of the same thing with gas. You know, if you know you have a lot of family coming over, you crank up your gas water heater, you have to remember to crank it back down. Okay. Okay. So how do you identify a heat pump water heater? All right. Um, they're all the major manufacturers now make heat pump water heaters. There's even a few that specialize in heat pump water heaters. Okay, so they're readily available. Um, there are two basic kinds. There's integrated, where the heat pump actually sits on top of the tank. All right, that's by far the most common. But there are another kind called a split system, where the tank and the heat pump unit itself are separate. And that's really cool because now you can put your heat pump outside. You can put your tank pretty much anywhere inside that you want to, and not have all the issues associated with putting it in too small of a volume and stuff like that. These are really, really efficient. They are expensive. They're Sandin is one of the main. There's a couple others that specialize in these, but it's an option. It's an option. Okay. Some of the features of a heat pump. Well, there's this little thing sitting on top of the tank that looks kind of interesting. And it's like a little small refrigerator. Using those little dormitory refrigerators. If you took all the guts out of that dormitory refrigerator, you could probably make a heat pump water heater out of it. And that's kind of what it sounds like too. So that's another thing is they make noise. Okay. But you're going to see this heat pump. You're going to be some sort of fancy digital control panel. Okay. And then you're going to see these vents. Remember, it's taking the heat from the air. So the air is going to go through this vent. It's going to get cooled. The BTUs are going to be extracted from it, and it's going to come out the other side. So that's a very common feature. Um, there is a large storage tank. So all the things that go along with the storage tank, you have to have the seismic straps and all that good stuff. Um, there's an electrical connection and no gas. All right. So that if you see all those things, that's a pretty good indication that it's a heat pump water heater. All right. The split systems, there's no heat pump on the tank. It's a separate unit. It'll have a large tank. It'll have a control panel, electrical connection, no gas connection. The condenser is a separate component. Doesn't that look very much like a mini split? If you've seen the mini split space heating, looks exactly the same. That's because it is pretty much darn the same thing. It's a heat pump that instead of sending refrigerant to heat and cool the house, it's sending refrigerant, or some of them actually heat the water in themselves. But you're going to see the unit will sit outside, the tank will be inside, and they'll be connected by either copper water pipes or refrigerant lines. Okay. Um, electric resistance water heaters. There's no heat pump on top. They're a tank. They have electrical connection, and they only have these electric resistance elements. Okay. I'm going to go back a couple slides to the heat pump water heater, and notice these two things here. This particular water heater, and most of these have electric resistance in them, and it's an upper and lower element. The electric element that gets hot. Okay, so most heat pump water heaters are basically they are an electric resistance water heater with a heat pump on top of it, so it can kick into that electric resistance mode if you really, really need it. And electric resistance can heat water very quickly, but it's expensive, remember? So you want to avoid that as much as possible. All right, electric resistance water heaters. Here we go. Here's that upper and lower thing. Okay. No gas, just electric resistance. That's all it is. Very simple, very plain looking water heaters. Okay. Gas water heaters, you're going to see some sort of a flue vent. This one's a little unusual. This is what we call a direct vent. All right, so it's blowing air directly out. Most of them, the flue is a single wall. It just goes up until it hits the roof, and then it's a double wall from there on up, and it goes out of the house. That's for all the combustion products to escape. So you can have some kind of flue gas piping. You have a large storage tank. There will be a gas connection. You'll see a gas pipe coming into it, and there'll be some sort of temperature adjustment knob. Okay, and a little button to relight your pilot light and stuff like that. So that's how to identify a gas water heater. Okay, some special considerations for heat pump water heaters, and I've alluded to this already. And how are we doing on time? We're doing pretty good. I only got 5 or 6 slides left. Yeah, I heard everybody say, yeah, he's only got 5 or 6 slides left. I'm just kidding. So special considerations for heat pump water heaters. What do we have to think about that we don't have to think about for other kinds of water heaters? All right. One of the big things is if you're switching from gas to electricity, um, they require electricity. Okay. And most of them require a 240-volt 30 amp circuit, which a lot of people don't have available in their current thing. So there are situations where you may have to upgrade your panel, but there's some really cool stuff going on right now. The way our electric panels work is really, really old fashioned. We get these circuits. We say, here's a 10 amp, here's a 15, here's a 20, here's a 30. And we say that all the stuff running on this thing can use up to that much electricity, and then if it uses more, it trips. Okay. And the way we size all that stuff is very antiquated. It's very old fashioned. We just kind of say, yeah, all those lights, they're going to use about 15 amps, and no, this is going to use this much. Um, and there's a much more efficient way to approach that. And so there's more modern ways of controlling electricity by having these very smart electrical management systems that don't rely on these old fashioned, you know, tripping breakers and stuff like that. There's also some pretty cool new things where you can share a circuit. So if you have a heat pump water heater and an electric car, those don't need a lot of electricity right now. They need some electricity kind of over a long period of time, and they can share a circuit. You can share a circuit with a dryer and a heat pump water heater. Okay, when you dry your clothes, it says, okay, this is priority. Let's run the dryer. And then when you stop drying your clothes, it kicks back. Actually, you don't want to put your water heater. I take that back. An EV is a better example. Okay, because if you dry your clothes too much, you can get cold water. People don't like that. Um, but EVs and dryers are a way to do it. Okay, so you can combine some of those circuits to free up space in your panel to put in an electric water heater. Um, there are some new ones coming out. Instead of being 240-volt 15 amp or 240-volt 30 amp, they're 240-volt 15 amp, so they can run on a smaller circuit. And there's 115-volt ones that are basically just your regular plug-in type of outlet. That's 115 volts. I've heard some people say that they're very quite pleased with their 115-volt heat pump water heater. There's only a couple of people living in the house, but it's working great for them. Okay. So there are controls available for sharing circuits, giving priority, dryer over water heater over EVs and things like that. So there you go. Okay, they do require ventilation, either a continuous flow of air passing through them or a large volume of air they can extract the BTUs from. The the general rule of thumb is 750 to 1,000 cubic feet. Now, to put that into perspective, that's less than a one-car garage. So if you imagine a one-car garage, you can put a heat pump water heater in a one-car garage, and that is enough volume for it to extract heat from. Okay, bigger is better, and warmer is better. Okay, this is not a code thing. This is a manufacturer's installation instruction thing. So you got to read the instructions for the specific water heater that you get will tell you what's the minimum volume. Okay. Some of them will allow you to put them in a closet as long as that closet has louvered vents on it. Okay. And again, what happens if you don't pay attention to this is the air inside that closet gets really, really, really cold over a period of time, and then it can extract heat as well, and the efficiency goes down. All right. So the preferred location is hot spaces such as a garage. The byproduct is cold air. Be creative with that. Okay. Um, I know someone who put a louver on. They you can buy these ducted, by the way. You can have them where the air is ducted into it and the cold air blows out through a duct, and so you can draw the air in from a specific location and you can blow it out to a specific location. And I have a friend who has one in his garage, and in the wintertime he just blows the cold air outside. In the summertime he blows the air inside. He throws a damper and it blows cold air inside his house. Okay, so there's different things you can do. Recovery time. It takes a much longer time for the heat pump to recover, to get back to temperature. Okay. And the general rule of thumb is if you replace a gas water heater, you want to go one size bigger. So if you replace a 30-gallon gas water heater, you may want to go to a 50-gallon heat pump water heater. If you're replacing a 50-gallon gas water heater, you may want to replace it with a 75-gallon and things like that. Okay. There's calculations you can do. There's people that'll help you figure that out. It depends on how many people are living in the house, how many bedrooms and stuff like that. Most heat pump water heaters have electric resistance for emergencies. All right. If you absolutely positively have to take a hot shower and you run out of cold water and it's going to take too long to heat back up, you can kick it into electric resistance mode and it will recover very quickly. Okay. All right. Consider models with connected functionality that allows mobile control and status checking. Okay, there are a bunch of heat pump water heaters that aren't Wi-Fi enabled, so you can't control it with your phone. Most of the nicer ones you can. All right, and it's good to do. It's good feedback. It's good information. Information is power, right? Set all controls as per manufacturer's instructions. Read those instructions carefully. I heard some people saying some really interesting thing, like efficiency mode. You'd say, okay, efficiency mode, that means it's going to use less electricity. No, efficiency mode meant it's going to give you hotter water. And so it had electric resistance built into it. So read those instructions and understand what it's saying. Okay. Oh, here we go. Our furnace has a pipe to drain condensate. Can the condensate different share that pipe? Yes, it can. Okay, so thank you for mentioning that. Um, heat pump water heaters, because they cool air, moisture condenses, and so there is a condensate line that it needs. It needs a place for that moisture to go, that water to go. It's just a very drip, 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 drip. It's not a lot. Okay. If you have a condensing furnace that has a condensate line, you can put the heat pump water heater line and share that line. Okay. But you can't go the other way around because the condensate from a furnace is the combustion products being condensed and the moisture is coming out of the combustion products. And there's stuff in that water that you can't just put anywhere. But the water from a heat pump, the condensate from a heat pump water heater is pure water. You can put it anywhere. Okay. And so you can share, share where they go. All right. Thank you for that question. Here's another question concerning split type, where the condenser and fan are likely to be placed between houses. How are you going to deal with the noise pollution, which can be very loud? I'm having that issue presently with my neighbor. Oh gosh, who has made my outside yard unusable. Yeah, so that is a consideration. Just like an air conditioner, just like a mini split space conditioning, it's a fan and it makes noise. Okay. So you do have to take that into consideration. That's only with the split ones. The package units, the unitary heat pumps with the heat pump on top of it, they give off noise, but that's inside your house and it's relatively quiet. Okay. I mean, it's like one of those little refrigerators. It does give off noise. You don't want it near a bedroom. Okay. But if it's in your garage, if it's in a closet, it's usually a non-issue. Okay. I'm sorry, I can't specifically help you with that issue. That's like a neighbor issue, but do be aware of that. If you're thinking about a split system with a condenser that sits outside, not just noise, but things like clearance. And I know that in places like San Francisco, um, they don't like to see those things. And so if you live in an apartment building, you can't just like slap it on the front of the building and where people can see it. So there's zoning issues like that you do have to be aware of. Are there any specific smart panels for electricity that you recommend? No, I don't recommend anything specifically. Do your research. You'll learn as much as I would if I did the research. All I know is that they're out there, and I've heard lots of presentations about them, and there's some really cool stuff happening right now. So yeah, do your research. There are a lot of cool stuff coming out right now. Okay, I'm taking too much time.
Russ, there's a couple in that made it into the chat too.
Oh, where did the chat go? I hid my chat. There it is. Awesome. Let's see. Oh, I gotta go back to there's a bunch of them.
No, you can start with because you addressed one of the earlier ones.
Yeah.
You can start with Urban Carmel, which is either a very cool name or like a nonprofit on the Central Coast. I'm not sure.
Yeah, Urban Carmel. Um, so bad idea to put a heat pump in a subterranean basement that needs warmth to keep it dry and prevent mold. Not necessarily, not necessarily. Because the earth is a wonderful source of heat, not the kind of heat that we want, but heat as opposed to being outside when it gets really cold. You know, you get down close to 0 degrees or 20 degrees in the Bay Area in the winter time. Um, the earth always stays about 50 degrees and it has an endless supply of heat. And so a basement or a subterranean place is actually a very good place for it as long as there's adequate ventilation. Okay. You've got to get that air, that cold air out of whatever compartment that it is in. Okay. Um, we won't have time. Oh, that's Julie. Urban, same question. Can you please talk about clothes dryers inside a closet and combustion air requirements? Let's see. Well, if it's a gas dryer, the pipe that comes out that you connect to your wall and send that out, that is like a B vent on a furnace. Okay, that's like the exhaust pipe on your car. Not as only moisture that you're trying to get rid of, but there's bad stuff in there. Okay, combustion products, and because flame is happening inside that dryer, flame needs oxygen to burn, and so you have to provide a certain amount. And I don't have time to discuss the details of that, but yes, you do need combustion air. It cannot be inside and enclosed. Same thing if you have a gas water heater in a closet, you have to provide it combustion air. Okay. Will recording be available? Yes. There'll be a survey at the end. How about a heat pump next to a gas furnace? Does it make the furnace less efficient? No, not necessarily, because wherever that cold air is blowing, it's going to blow it away. I mean, if it's in the same space, you're putting cold air around the furnace, but that's a minor impact on the furnace as long as it's not super leaky and sucking in that cold air. But the furnaces give off heat, and so the water heaters are going to say, thank you for all this heat that you're wasting. I'm going to put it in this water. Okay, but it's only when the furnace is running that works. It's a very complicated formula for that, but generally speaking, it helps the water heater. It doesn't hurt the furnace too bad. Now, another thing is if you're blowing that cold air into the house, you're taking BTUs out of the house and putting it into the water. And taking BTUs out of the house means you're cooling the house, which means the furnace has to put more BTUs back into it. Okay, so the furnace, the BTUs that are going into the water are originally coming from the furnace, if that's the case. Okay, your water heater is inside your conditioned space. Let's see here. I think that's it on that. That's it on that. Okay, let me wrap up here. Let me make sure I got all these bullets. Operating modes, got that. Heat pump modes can be set for year-round use if the conditions are right. Avoiding use other modes that may use energy needlessly. Okay, understand your controls. Understand your controls. And let me say this too. The Bay Area is the perfect climate for heat pumps. Heat pump space heating, heat pump water heating. If you could invent a climate that was perfect for heat pumps, it would be very much like the Bay Area is. Okay. Mild winters, mild summers. Okay. And they work great. They work really, really well. I have friends in Minnesota. I have friends in Chicago. I have friends in Pittsburgh that where it gets below zero in the wintertime. They have heat pumps on their house and they work great. Okay. All right. So Bayron has this really nice permit guide. So if you're thinking about replacing a gas furnace with a heat pump water heater, there are certain things you have to do. Okay. And this does a very nice job putting it all into one nice, concise place. And obviously call Kellen and his team if you guys have questions, the Bayron folks, if you have questions about rebates and all that good stuff. And I'm sure they have some stuff to talk about. And that is the end of my presentation. Happy to answer any questions.
Thanks, Russ. We had one come in the QA. Can heat pumps be installed with hydronic systems? So there actually are a couple neighborhoods with a lot of Eichler homes in Marin County that have existing hydronic systems. So I wonder if you can touch on that. Do they have heat pumps that can be
They do.
retrofitted
They
for
do.
those?
Yes, they do. It's you want to be very, very careful if that heat pump is also providing domestic hot water. When you have a water heater that provides space heating and domestic hot water, that's called combined hydronics. Combined hydronics, okay? And that gets really, really tricky to size those correctly because now you're taking showers is fighting with your space heating system over that hot water. The simplest way to do it is to have them be separate. Okay, have a heat pump water heater that serves your space heating and then heat pump water that serves your domestic hot water. But you can do both. You just have to do your research. When heat pump water heaters, 8 or 9, 10 years ago, when they were first coming out, the second phase of heat pump water heaters, you didn't want to do that. But now they're coming up. Now there's heat pump water heaters that will serve multiple apartments off of one water heater. So they do have heat pump water heaters that have a lot of output, and that's what it's all about: is their output, how many BTUs worth of hot water can they put out, and then their recovery time, how long does it take? And so they have heat pump water. They basically just have a bigger compressor on there that puts heat into the water faster. So it is possible. You just have to do your research. Yep.
Great. I did want to spend 1 second just addressing rebates. So Russ, actually, while you were presenting, an email came in from Tech Clean California.
Mm.
And I'm not going to read the whole thing, but basically the Energy Commission provided a statement that said, because of the executive order from the executive branch on, January 20th, they decided to pause HERA, which was the home electrification and appliance rebates portion of the IRA funding. So not great news. I'm obviously a, county employee. I'm not going to get political or anything, but I will say that in my professional experience, the state of California is pretty um, motivated for the switch to electrification, and the Tech Clean California program was originally funded by state dollars. So just because these opportunities are maybe being paused or could be going away, I wouldn't be too discouraged. One thing that we've seen over the years is price coming down as more contractors are offering, heat pumps for space heating and cooling, and also heat pump water heaters, and also more manufacturers getting into the game, along with local rules and regulations that are kind of pushing for more adoption. So, yeah, again, I wouldn't get too discouraged about that. It's stuff that's out of our control. But yeah, just to be aware that some of those state incentives looks like they've been paused. Thank you, Gene, for pointing that out and centering that discussion. But yeah, and then at the same time, Marin County, we have our own rebate program for folks that live in Marin, called Electrify Marin. Oh, Sarah's on video. Sarah, do you want to give a little preview or quick intro and rundown on Electrify Marin?
Sure, yeah. I'm Sarah Thatcher. I'm a program coordinator with the sustainability team. I'm specifically the go-to person for Electrify Marin, our rebate program that Kellen shared the link for just recently. And it is a rebate program for single-family property owners for removing and replacing a gas appliance with a heat pump, water heater, or a heat pump, central air source heater, or an induction stove. So you can look into that at that website, and you can reach out. My contact information is on there. So give me a call tomorrow or anytime if you have questions about our rebate program specifically.
Awesome. Thanks, Sarah. Well, I'm not seeing too many questions come in, so I think we can give folks back a couple minutes of their evening. Thank you, Russ, for the presentation. Do the state programs apply to townhomes? Yeah, usually depending on, yeah, they do. Yeah, especially if it's like 1 to 4 units, that's considered single family in the energy world. So yeah. But yeah, and for folks that are looking into heat pumps for space heating, Russ is gonna be back next Wednesday to talk about that topic. You can find registration on our website on the event section. And another question came in from Vicky. Yes, so those rebates are on pause. That was actually just the one portion of the Inflation Reduction Act rebates through the HERA program, and also the tech program, which was the state-funded one, recently just ran out of funding. So, but that's happened a couple times, I think maybe 3 or 4 times at this point. Tech has, launched a program and then run out of funding, and then they get more money and then they launch it again. So again, not to be too discouraged, it's not the end of the world. There's going to be more funding for these projects. And, it does get more complicated with things coming and going. And, knowing who to talk to. But we're a good resource, especially for everybody in Marin. We keep our website updated with, the current offerings. And yeah, and our, phones and emails are open to everybody in Marin that need help with these projects. So don't hesitate to contact us. Okay. Well, I think we can call it. I hope everybody has a great night. Thank you for attending today. And oh, we keep getting some last minute questions. So here's one from Gene. What does it cost to do solar heated water compared to electric heat pump? And would the county consider doing a webinar on this? Russ, I don't know if you have any information on solar heated water costs. I feel like it's a thing that went away in like the 80s and 90s, and now it's coming back. I'm not sure
Yeah.
if we have any estimates on cost. But Gene, that's a good point. In the survey, and I'll share the link one more time. We have a section on there of like, hey, are there any topics that you think we should organize a speaker around? Feel free to put that in there, and we look
Yeah.
at those, and yeah, so we can bring those in the future. But yeah, Russ, I don't know if you have anything on that.
All I can say is that I actually had a summer job knocking on people's doors trying to sell hot water heaters one summer. It was a miserable, horrible job. There was a whole bunch of money thrown and at trying to get people to put solar water heaters on their house, and they were installed too quickly, and they didn't work very well, and they left a bad taste in a lot of people's mouths. And you still drive around, you can still see them on people's roofs, and they're probably shut off because they no one trained them how to use it and stuff like that. But it's undeniable that it's a great way to do it. Where you still see a lot of thermal water heating is on swimming pools. That's a very popular way to heat your swimming pool, is to put a thing on your house, and they can do that for domestic water heating as well. So they are coming back. The technology is improving. They're getting smaller, a smaller footprint on your roof, and they're getting much more efficient. So you will start seeing more and more of it as we go.
Awesome. Thanks, Russ. Well, yeah, let's leave it there. Once again, thanks everybody. Thanks, Julie, for the tech support. Thanks, Sarah, for tuning in. And yeah, we'll see everybody next time. Have a good night.